Okay, here we go. Introduction to Boolean Algebra. It's fairly simple. What I've done here is I've taken the...
According to Wikipedia, Boolean algebra was introduced by George Boole in his first book, The Mathematical Analysis of Logic, and set forth more fully in his An Investigation of the Laws of Thought.
Well, there you go. So Boolean algebra is fairly simple, and I've written the truth tables here for the AND and the OR gate. And if we take a look, okay, so we know an AND, we're only going to get a high when we have a 1 and a 1. And for OR gates, we're going to get a high anytime there is a high on any one of the inputs. So I've drawn this is the AND gate, and this is the OR gate. And if we take a look at it, we go, okay, well, Boolean algebra says, well, okay, well, if I've got a high on 1, and I've got a high on 2, so high on A, high on B, I can end up having a high over here. But from an algebra standpoint, we say, well, okay, well, what is the algebraic equation equal, or y is equal to, and we'll say y is equal to A times B. And the reason we're going to say it's A times B, we're not going to say A plus B. So we look at the truth table here, and if we say, well, this is either going to be, from an algebra standpoint, it's either going to be multiplication or addition. And if we look at this, we go, well, let's take a look at if it was addition. If it was addition, 0 plus 0, 0, 0 plus 1 is 1. Well, that's not right. 1 plus 0 is 1, 1 plus 1, well, we can only have either a 1 or a 0 state. So it doesn't make sense, though, if I go 0 and 1 there. 0 plus 1 is 1. But it does make sense if I say 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1. That makes sense. So it means that the AND gate must be a multiplication. So I'm going to put the AND gate in there. Multiplication in the AND gate. If we look at the OR, and we say, well, a high on A and a high on B, I'm gonna get a high on Y. And I could say, well, from a Boolean algebra standpoint, I could say A plus B is equal to Y. So we say, okay, well, it's a plus. Now we'll take a look at it over here. And why is it a plus instead of a multiplication? Well, we go look at the truth table. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1. Again, it can only have either a high or a low output. So that makes sense from that perspective. Okay, so now we look, and I've changed something here. So I've kept my AND gates, but what I've done is I've taken an additional AND gate and put it on the output of this one here. So this was Y before. And I've done the same thing over here. And if we look at this, you say, okay, well, from a Boolean standpoint, I know that if I have A here and B here, then my output, if this is a multiplication, is going to equal A times B. And over here, my input there is C, and I'm still multiplying these together. So my output here would be an AB in there, and a C here. So my output would be A times B times C. Now, if we take a look at the OR gate, much the same way. I got an A plus a B. So this would be right here, A plus B. And then this input here is a C. So now I've got A plus B going into a Y. So my Y is going to equal A plus B plus C. Okay, so I've changed it again, and as you can see, I've still got my AND gate going into an AND gate, and then it's going into an OR gate. We know that the OR gate is going to be plus. And then this one, we've got an OR gate going into an OR gate, and this is an AND gate, so we know that that is going to be multiplication. So let's take a look at this. I'll make that D. So we have 4 inputs here, A, B, C, and D. So let's start here, A times B, so that's going to be outputting AB. I've got C coming in here, so it's multiplication, so I'm going to be having coming out here A, B, C, or A times B times C. And I've got D going into this output. So now we're going into an OR gate, and we're going to say, well, Okay, if I look at this from an algebra standpoint, I got A times B times C, and then this is plus D. So my y is going to be equal to A times B times C plus D. That plus is coming as a result of that OR gate. And then we look at this one here. We got an OR gate here. I got A plus B. So this one's going to be outputting A plus B. I'll just fix that. A plus B. And I've got a C input on this one here. And this is again, this is going to be A plus B plus C. And then I'm going into an AND gate over here, which is multiplication. That D goes to there, so it's that D there. And then so I've got A plus B plus C times D. So it's going to be equal to A plus B plus C times D.